Today's high-definition video displays are progressive scan, forming images with an array of pixels. Each frame is displayed in its entirety, all at once, with all pixels being activated simultaneously to form the complete image. However, most video sources, including DVD, standard definition TV, and 1080i high-definition TV, transmit interlaced images. Interlaced video sources, unlike progressive, transmit only half of the image in each frame at any given time. These two half frames are called fields. The first field consists of every other line of the frame. The second field fills in the lines that were skipped a fraction of a second later. Digital displays ultimately require a progressive signal to operate properly, so if they receive an interlaced signal, it must be converted to progressive before it can be displayed. If the objects in the video aren't moving, it is very easy to do the de-interlacing. The two fields can be weaved together and combined to form the complete frame. However, recall that one frame is recorded as odd fields from one point in time, and then as even fields that were recorded 1/50th or 1/60th of a second later. So if an object in the video has moved in that fraction of a second, simply combining fields causes the errors in the image called combing or feathering artifacts. The simplest approach to avoid these artifacts is to ignore the even fields. This is called non-motion adaptive de-interlacing. In this method, only one of the two fields is used by the video processor. The video processor will recreate or interpolate the missing lines by averaging pixels from above and below the row. While there are no combing artifacts, image quality is compromised by discarding half of the detail and resolution. HQV processing represents the most advanced de-interlacing technique available, a true pixel-based motion adaptive approach. When the two source fields are presented to a product with HQV processing, motion is identified at the pixel level rather than the frame level. While it is mathematically impossible to avoid discarding pixels in motion, HQV processing is careful to discard only the pixels of the image necessary. Everything else is displayed with full resolution. Pixel-based motion adaptive de-interlacing avoids artifacts in moving objects and preserves full resolution of non-moving portions of the screen even if neighboring pixels are in motion. To recover some of the detail lost in the areas in motion, HQV processing implements a second-stage multi-directional diagonal filter that is able to reconstruct some of the lost data by identifying edges of moving objects, resulting in smoother images more faithful to the original.